Question 12. Put these numbers in order from smallest to largest. So we've got 8 times 10 to the minus 4. So you probably know that you can just write 0.123 4. 4 times 10 to the minus 2, 0.12. 6 times 10 to the minus 4, so 0.1234. And 0.07 is already in this format for us. The easiest way to compare them is to make them have the same number of digits. So if we put 2 zeros there and 2 zeros there, and then if you hide the 0.0 in each case, you've got 008, you've got 400, 006, and 700. And looking at it like that, you can see that the biggest one is going to be that one. The smallest one is that one. We can write 6 times 10 to the minus 4 in the smallest. 0.0008 has got 2 more in that column than that one, so it must be that one next. It's a little bit bigger. This one is really quite big in comparison to those two, so that is 4 times 10 to the minus 2 and 0.07. So we've written them exactly in the format that they were presented to us. Question 13. Circle the volume that is the same as 15 cubic centimeters. Well, let's look at 1 cubic centimeter. One little cube, 1 cubic centimeter. You will remember that a centimeter, that distance there is 10 millimeters, and that's 10 and that's 10. So let's just draw that out. Here's that little cube. And that is 10 millimeters. That is 10 millimeters. And the height is 10 millimeters. So the volume of that little cube, let's just make that a bit clearer, is 10 times 10 times 10. 10 times 10 times 10. And you know that 10 cubed is 1,000. So we've got 1,000 cubic millimeters in that cube there. So if we've got 15 of those, we must have 15,000. There it is. Question 14. Patterns are made using straight lines, there's the straight lines, and arcs, those little curves, arcs. So in pattern 1, we've got 1, 2, 3, 4, 5. So let's put straight lines. We'll put 5. The S stands for straight lines. I could have written L, but I wrote S. Let's write A for arcs, and there are 8 of those in pattern A. Pattern B, there's 2 rows in here. You can see that there are 10 straight lines. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 arcs. So I'm going to write this again down here. I'll write S and A again. And we've got in the first pattern, so pattern number 1, we've got 5 straight lines and 8 arcs. Pattern number 2, we've got 10 straight lines and 12 arcs. And we are looking to get the number of straight lines to the number of arcs to be 10 to 9. Well, that one clearly can't be, although it's got a 10 there. The ratio is certainly not 10 to 9. I think what this does tell us, though, is that the number of straight lines will be a multiple of 10. So let's keep going. Pattern 3, that's gone up by 5, gone up by 4, not a multiple of 10. Pattern 4, that's going to go up by 5, so that'll be 20. This one's going up by 4, so that'll be 20 as well. Pattern 5. That's going to be 25, that's going to be 24. Pattern 6, that's going to be 30, that's going to be 28. So 3 10s are 30, but 3 9s, that's what we're looking for. 3 9s are not 28, they're 27. And we're looking for that relationship. Okay, pattern 7 is 35, and that'll be 32. Pattern 8, that's going to be 40, because it's 5 more. 4 more than that is 36, so we've got a multiple of 10. Let's check this then. 4 10s are 40, 4 9s are 36. Yes, there is the pattern. The number of straight lines compared to the number of arcs is in the ratio 10 to 9. Now the question said, how many rows are added? Because at the top we've got as far as pattern B, which I'm calling pattern 2. There's pattern B. Perhaps I should have called them A, B, C, and so on, but never mind. There's pattern B. So we have added 1, 2, 3, 4, 5, 6. We've added 6 rows. Right, 14b, a different pattern is made using 20 straight lines and 16 arcs. So it's a completely different pattern. The straight lines and arcs are made from metal. 20 straight lines cost £12. The cost of one straight line to the cost of one arc is 2 to 3. Work out the total cost of the metal in the pattern. This is the type of question where you look at it and you think, I've got no idea, I don't know where to start. Think about it, let it mull around in your brain for a minute. They've told us that 20 straight lines cost £12. Well, let's find the cost of one straight line. So we're going to do £12 divided by 20. Well, £12, of course, is 1,200 pence. Dividing that by 20, we can remove a 0 from each. So we've got 120 divided by 2, which is 60 pence. That's the cost of a straight line. The arc is 2 to 3. So if 60 pence is sort of 2 shares, then 3 shares will be 90 pence, because 2 30s make 60, 3 30s make 90. So the ratio of the costs is 60p to 90p. Now we know we've got 20 straight lines, so we know that 20 times 60p is £12, because they've already told us that anyway. Now all we need is 16 times 90p. So a bit of working out over here. I will do it this way up. Although 90 is a larger number, by doing it this way up, I can simply put a 0 straight in there. 6 9s are 54. 1 9 is 9. Add 5 makes 14. That is £14.40. Remember, that was 90 pence. And in pounds, that's £14.40, which I'm putting straight under there. And we can add those straight up. So 42, add 4 is 6. 1 and 1 is 2. The total cost is £26.40. So a very unpleasant looking question actually isn't too bad at all. Question 15. A biased dice is thrown. Here are the probabilities of each score. The dice is thrown 200 times. Work out the expected number of times the score will be odd. So odd numbers are 1, 3, and 5. So if we add up those three, 0.25, 0.15, and 0.3, just add those up. Put a 0 there if it's easier. 5 add 5, a 0 there, 1 there. 1 add 3 is 4, 5, 6, 7. So the probability of getting an odd number is 0.70, 0.7. So we've got to do 0.70 times 200. Now the easy way to do this is to say, well, that's 0.7 times 2 times 100. So use that 100 to move that. 100 times 0.7 gives us 70. 70 times 2, we would expect 140 times to get an odd number on this biased dice. Question 16. The value of y is 20% more than the value of x. Circle the ratio x to y, and then we've got 4 choices. Okay, well, if it's 20% more than the value of x, we could write a little equation, y equals 120 over 100 times x. Having got that, let's simplify it. First thing, just cross out those zeros. So 12 over 10 times x, which is actually 6 over 5 times x. That means that y is 6x over 5. Multiply across, 5y equals 6x. They haven't left us much space here. I'm going to write it down here now. So they want the ratio x to y. So I'm going to write 6x equals 5y. Now the way I'm going to do it is divide both sides by y, so 6x over y equals 5. And now I'm going to divide both sides by 6, so x over y equals 5 over 6. And we can express that in a ratio form, x to y equals 5 to 6. So that's the answer there. Only 1 mark for quite a lot of thinking. Now, question 17. Here is a triangle. Circle the correct equation, and they've given us a choice of 4. Well, you've probably guessed that we're going to need to use the sine rule. So let's look at the sine rule. A over sine A equals B over sine B equals C over sine C. But remember, all of those can be flipped up the other way. So you could have sine A over A equals sine B over B equals sine C over C. Now let's look at the information we've got. Let's give the triangle some letters. I'm going to call that one A, that one B, and that one C. Now you can see from C that it hasn't got an opposite side given to us. We're not really interested in that part of the equation. So we're only looking at the A's and B's parts. Let's try them in there. So x is a length over sine 42. X over sine 42 is equal to 15 over sine 104. Oh, and actually, we've got it straight away. It's that one. It couldn't have been that one because that said sine x. Well, x is a length, not an angle. Similarly with that one, it couldn't be that one because x is a length and not an angle. And if we look at this one, we've got the x over sine 42 is right, but then the 15 over sine 34, the 15 has to be opposite the angle that we are using, and it's not, it's adjacent to it. So that one doesn't work. So there we are. This is a 5-mark question. Here is a tunnel for a toy train. The diagram below shows the cross-section of the tunnel, so what the end of it looks like. And you can see they've labelled it A, B across there and C, D across there. So that's A, B, C, D. And that outer arc, that outer semicircle, has a radius of 10 centimetres. The inner semicircle has a radius of 7 centimetres. They're saying AD is a semicircular arc of radius 10 centimetres, BC is a semicircular arc of radius 7 centimetres, and the length of the tunnel is 30 centimetres. Work out the total area of all 6 faces of the tunnel. They're not asking for the volume, they're asking for the area of all 6 faces. So let's try and work out what those faces are. We're looking for the area of the foot of the tunnel there and the foot of the tunnel there, but also then the inside curved part and this outside curved part. It's like there's a sheet of paper over the top of there, and we've got to find the area of it, and a sheet of paper stuck on the inside of there, and we've got to find the area of that, and the arc at each end. Let's do the feet first, because I think that's going to be easiest. This foot here is 30 centimetres long, and it's 3 centimetres wide. So 3 times 30 is 90 square centimetres. So that's that foot. I'm calling that face number 1. Face number 2 is the other foot. So that's going to be the same because it's still 3. 3 times 30 is 90 square centimetres. So we've got 2 of the faces already. Now it's going to get a bit harder because we're looking now for the area of this. Now the area of that is, well, let's pretend it's a complete circle. Not a very good drawing there, but if it's a complete circle, so there's the circle in the middle and we want the area of that. So if we find the area of that whole circle minus the area of that circle and then halve it, or find that half first and then subtract that patch out of it. So the area of the whole circle would be pi times 10 squared, which is 100 pi, but we've got to take away pi times 7 squared, which is 49 pi, taking away all of that from all of that. So we're left with 51 pi, but that would be the area of the whole circle. We only want half for this one, but actually we want the other half for the other end of the tunnel. So we'll stick with 51 pi, so that's 3 and 4 together. So what's really quite an unpleasant question, it seems, well, it's getting easier. So far, we've got the area of that foot, the area of that foot, and the area of those 2 faces. Now we need the area of the top sheet of paper, if you like, if it's going like that around the top of it. The area of that is, if we could sort of unwrap it, we would have a rectangle that is 30 centimetres that way, and the other length of the rectangle is half of the circumference of the circle. The circumference of the circle, as you know, will be 2 times pi times the radius, but we only want half of it, so it's going to be pi times the radius, which was 10, so 10 pi. That is the length around there, a half of 2 pi r. 10 pi times 30, so we've got 300 pi. 3 and 4, remember, were 51 pi. The outer surface is 300 pi. Inner surface, this sheet of paper here, so using the same principle, it's going to be a rectangle that is 30 centimeters long, but how wide is that rectangle? It is a half of the circumference of that whole circle. So 2 times pi times r, but we only need pi times r because we only want half of it, so that is 7 pi. 30 times 7 pi is 210 pi. The total area of all 6 faces is this lot added together. So that is those two, which is 180 square centimeters, plus 300 and 210 is 510, 561 pi square centimeters. So let's write that again. 180 plus 561 pi square centimeters. Question 19. Type A batteries and type B batteries were tested. The cumulative frequency diagram shows information about the battery life of type A. Cumulative frequency, battery life. Estimate the interquartile range for type A. Looking at the graph, we can see that there were 80 type A batteries, because that's the very top of it. Halfway to 80 is 40, so that's there. Halfway to 40 is 20. This is what we really want, because we're looking for the lower quartiles. Drawing across from there to the graph, so that's 1100 hours. And the upper quartile, there's halfway, look at 40. The upper quartile is there at 60. The upper quartile, of course, is halfway between the median at 40 and the total at 80. So coming down from there, we've got 1400, we've got 1100. That's the lower quartile, that's the upper quartile, lower quartile, upper quartile. So the interquartile range is 1400 minus 1100, so that's 300 hours. Part B says, estimate the number of type A batteries that had a battery life of more than 1600 hours. More than 1600 hours, there's 1600 hours. So if we go up to the graph from there and go across from there, we get to there, and look, there's 70, 72, 74, 76, 78, 80, about 76. So there are just 4 batteries that had more than 1600 hours, because there's 76 up to 80, so it's 4. Right, here's question 19C. The box plot shows information about the battery life of type B. On average, which type had the greater battery life? Tick a box. Was it type A or type B? Use data from both diagrams. State how you chose your answer. On type B, we can see that the median was 1300. There's the upper quartile there and the lower quartile there, but I'm going to use the median at 1300 hours. Let's look back now at type A. Let's go across from 40 and come down to the graph from there. Now let's look carefully at this. That's 1200, that's 1300. So I'm guessing each of these is 20. So 1220, 1240, 1260, 1280, 1300. So it's looking like 1260 or 1260 hours for A. A was 1260. B was 1300. So I'm saying type B. And I've got to state how I chose my answer. So the median number of hours for type A is 1260. The median for B is 1300. That's all that's needed. Question 20. A linear sequence starts A plus 2B, A plus 6B, A plus 10B. The second term has value 8. So there's the second term, and that's worth 8. The fifth term, which we haven't got yet, has value 44. Let's find the fifth term. So each one, it appears that A is not changing. So A plus, there's the fourth, there's the fifth. 2B to 6B is 4B. 6B to 10B is 4B. So we're adding 4B every time. So that looks like that's going to be 14B. So that one will be 18B. So now we know that A plus 6B is equal to 8. And A plus 18B is equal to 44. Now you might be recognizing that these are in fact simultaneous equations. So let's call that one A and that one B. And because B has the larger figures in it, and also because there's just A on both of them, I'm going to do equation B, subtract equation A. Let's write B again here. A plus 18b equals 44. And we'll write A again here. A plus 6b equals 8. And then we're going to do B, subtract A. But of course, A take away A is 0, so we don't even need to write anything down. 18b take away 6b is 12b. And 44 take away 8 is 36. So B must be 36 divided by 12, which of course is 3. If we substitute that value into equation A was A plus 6B equals 8. Now we know that B is 3, so we know that A plus 18 equals 8. Now I'm going to subtract 18 from both sides, so A equals 8 minus 18, which is of course minus 10. A is minus 10 and B is 3.